Mm. So related to continuity, we have continuity of a function at a point. Point means some x value. And another is continuity of a function on interval AB. Another is continuity of a function. Other terminology what we have is right continuity and left continuity. Finally, continuity on total real line. Here, basic definition of continuous function. A function f is said to be continuous at x equal to a if limit extends to a f of x is f of a, or limit extends to a minus fx, a plus fx equal to f. These are theoretical definitions. What exactly this? What exactly discontinuous? What exactly continuous? Any graph, if you take, for example, like this graph. Graph means what? It is a function. You have different y values for different x. This graph is discontinuous at some point. Some point means y is discontinuous at a because there is a gap. So that gap, what they say, how they express in uh, theoretically. Here, if I take limit extends to a plus fx as a 3, limit extends to a minus fx as 2, the graph will be like this. A minus it is 2, a plus will be it is 3. Right, I want to discuss its continuity at a. A minus is 2, a plus is 3. That means these two are not equal. Limit extends to a plus fx is not equal to limit extends to a minus fx. We say f is does not exist as well as f is not continuous at x equal to a. Sometimes it happens that the limit equal one-sided limits. A plus is one-sided limit, right limit. This is left limit. Still, function need not be continuous. Let us take an example. F of x as plus 4 x greater than a 5 at x equal to. If I take this one here for at some particular value of x less than a, it will be 1, 2, 3, 4 here. Less than a, it will be 4. And at more than a, it is again 4. Right? Left limit and right limit are same. But still there is a gap at x equal to a. He defined it as, right, how much? 5. So there is a gap. Even left-right limits are equal, function need not be continuous. In case that functional value is also 4, in case functional value is 4, then there won't be any gap. We say f is continuous. That means a functional value also plays a vital role. Not only left-right limits, value at that particular point also matters. Right. So this is what the importance of functional value in the role of continuity. Now here, while discussing many problems, we should know which are continuous functions, which are discontinuous functions. If you take f of x as x, and here it is nothing but fx is nothing but y equal to x will be a straight line passing through the origin. Generally, we many of you know that we can draw a straight line, but y equal to x also may be a discontinuous function. How? F map from 1 to 3 to R. F of x, if I define it as x, so it is not a continuous because the input what we are taking x is 2, x is 3, 3. You cannot join because 1.1 is not there in the set, only 3 values. There is a lot of gap. So it is discontinuous. That means only by seeing function we cannot say continuous. If you take domain as real number in the sense, if you take natural 1, 2, 3, so on, but there is a lot of gap. So between 1 and 2 you take a lot of gap. So 1.1, 1.2, 1.3, like this all the values will be there, including rational, irrational, everything will be there. So real numbers is a connected set. As it is a connected set, then we can say you have a no, you can form a line if you take domain. to make function continuous. So the role of continuity is it depends upon function as well as the domain where it is defined. So generally we discuss domain continuity either on real numbers or on a defined region. What I mean by defined region, if I take f of x as log x, it is not defined for all x. So in the domain it's defined only for greater than zero, that is zero to infinity. So we can't discuss its continuity over real numbers. Root x, we can discuss its continuity over this. So what do you say about its continuity on minus infinity zero? Means once it is not in domain, suppose x equal to a at x equal to minus 2, is root x continuous? Simply answer is discontinuous. Once it is not there in the domain, we say it is discontinuous. So like that, uh, which are continuous functions, which are discontinuous functions means first point here is all polynomials are continuous functions on real numbers. That means what are polynomial? X, x square, x plus x square, 2x plus x square plus x cube. These are all polynomials. So generalized format will be a naught x power n, a1 x power n minus 1, so on. Is a polynomial of degree n. So all these are continuous functions. So other continuous functions we have is sin x. You take graph like this, cos x is also continuous. So other than polynomial and sin x, are there any continuous function throughout real line? Yes. You take mod x. It is defined as plus x for x greater than 0. So defined as minus x for x less than 0. So nowhere breaks. It is continuous. So what else functions we have? Power functions, 2 power x. As x is 0, it is 1. X is 1, it is 2. X is minus 1. So the graph look like this. Nowhere breaks. X increases, its value increases and goes up. So can you tell me some other functions which are continuous throughout the real line? Anybody other than polynomials, sine, cos, and power functions, right? 2 power x or e power x, these are all continuous functions. Now you have another point here, f continuous, g continuous, f plus g continuous. For example, it is a polynomial, it is trigonometric, is continuous, which does not comes under this model. F minus g continuous, f g continuous, f by g continuous provided g not equal to 0. For example, I can say sin x continuous, is continuous except at x equal to 0. So other than the case which are formed by formation of basic continuous functions, let us see. We have seen many continuous functions which are continuous, but domain is not real. Not real means part, part of real number system. Suppose you take log x function. Is it continuous where it is defined? Log 1 0, log 10 1, log 1 by 10 minus 1. So the graph look like this. As x is approaching 0, it approaches minus infinity. So it is continuous, not on real, where it is defined. So now let us take some other function, root x, where it is defined 0 to infinity. How the graph look like? Y square equal to x is a parabola, but y equal to root x will be this, only upper part. This lower part will be y equal to minus root x. There is no break. It is continuous in the interval 0 to infinity. And is there any other function which are continuous on the domain, not on real numbers? Is there any function whose domain is real numbers but still discontinuous? Signum function is defined as +1 for x greater, -1 for x lesser. So graph look like is a coordinate axis. For 0, it is 0. For greater than 0, y is 1. Like this. For less than 0, it is minus 1. So it is defined for all x other than 0. So other than this, do we have any other functions whose domain is real number but not continuous for all x? Here you take a graph of this function 0 to 1. It is 0 because box of 0 will be 0, box of zero point 0.1 will be 0, box of zero point 0.9 will be 0. Between 1 and 2, it is 1.1, 1.2, 1. When it comes to 2, it is called step function. If less than 0, here it is minus zero point 0.5 means in output should be less than the input. Less than minus zero point 0.5, there are many integers. Greatest among those is minus 1. So like that, it is discontinuous. Not all values, but all integers. Where it is continuous means other than integers, it is continuous. If you ask, is it continuous at 1.5? Yes, it is continuous. Is it continuous at 2? No, there is a gap. Is it continuous at 2.5? Yes. So this is function. So it is continuous all real numbers other than integers, but domain is real numbers. Right? No. And if you take what is meant by here in the beginning, as I discussed, few terms, right continuity. So here you have actually you have to check all one-sided limits. This is for a plus equal to only right limit. So we don't check left limit. We say f is the right continuous at x equal to a. If you write a minus f of x equal to fc, we say f is left continuous at x equal to a. Why these are important? If they ask, is f continuous on the interval ab, then cannot check left limit. At a, you can only check right limit, right? At B, you cannot check right limit. At B, you can check only left limit. So here, F is said to be continuous. At A, right continuous. At B, and it is continuous on open interval AB. These things happens, we said function is continuous on the closed interval AB. Let us apply all these to solve the problems. If I just now I told step of x is where it is discontinuous at integer because in the interval is mentioned there are many discontinuous points 1 2 3 and all. What about this total integer step of x plus 1 by 4 is you can make it as x plus 1 by 4 as y, then step of x plus 1 by 4 will be step y is discontinuous at y0 minus 1 1 like that. Y0 means x will be minus 1 by 4. Y is 1, it will be 3 by 4. Y is minus 1, it will be negative. If you take y as 2, 2 minus 1 by 4 will be it is 1 1 3 by 4, but our interval is 0 to 1. I can't take negative values. Is discontinuous at x equal to 3 by 4. Step of x plus half is discontinuous similarly at x equal to half. Take it as y. X plus half should be 1. X will be half. X plus half is 1 or 2 like that. If you take 2, it will be 1.5. It is outside the closed interval. X plus 3 by 4 is discontinuous at 1 by 4 because around 1 by 4 it becomes integer. So before after integer there will be a gap. So number of points of discontinuity will be 4 points of discontinuous in the interval. What are the 4 points of discontinuity? 0, 1 by 4, 1 by 2 and 3 by 4. These are the points of discontinuity. So here how the interval continuity plays a role. If I give a question f of x as x square plus 1, x belongs to 1 comma 2. At x equal to 1, 2. At x equal to 2, if I define as 4. My question is f continuous on closed interval 1 comma 2. So first step is a polynomial continuous on open interval 1 comma 2, right? Graph will be x square graph is this, x square plus 1 graph will be this. Between 1 and 2 it is continuous. To check continuity at 1, I have to take only right limit 1 plus f of x more than 1. Function is defined as this, and which is equal to function. So we say f is right continuous at x equal to 1. Still, I cannot say it is continuous on that. I have to check continuity at x equal to 2 also. At 2, I cannot check right continuity. 2 minus f of x. 2 minus means less than 2. Less than 2 function is this, which is not equal to f of 2, because f of 2 is defined as 4. The final conclusion is it is continuous on one open interval 2. Right? Discontinuous, right, on the interval, because it is discontinuous at x equal to 2. Or we can say right continuous at 1. It is not continuous left continuous at x equal to 2. Right. Here you have a another question. Continuous and differentiable. As long and what he is asking, then range of a where it is continuous. By seeing the question, what are the functions involved? Cost function, no problem. It is continuous. Sine function, no problem. But here you have a greatest integer function. As long as this function is there, it is discontinuous. How to make it continuous? So what we have to do is we have to eliminate that. If you don't eliminate, it becomes definitely discontinuous function. How elimination can be possible? X, he told, lies between 4 and 6. X minus 2 lies between 2 and 4. X minus 2 whole cube lie between 8 and 64. So how to vanish this step function means if I take a as greater than or equal to 64, like less than 64 is numerator, denominator is more. It is something like 0.99, which becomes 0. Entire thing can be vanished. That is, a belongs to 64 to infinite. Then we say step of x minus 2 by a whole cube will be 0. Then a function will be left over with only a cos x minus 2. A is a constant, x minus 2 is a polynomial, continuous, and I didn't discuss differentiable, all polynomials are differentiable. So therefore, answer is a belongs to 64 to infinity. Then we say it is continuous as well as differentiable everywhere. Right.
సార్
Yes.
సార్ నాకు అక్కడ సెకండ్ లైన్ అర్థం కాలేదు సార్.
This line.
ఎస్ సార్. ఇఫ్ ఏ ఇస్ గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు 64.
If maximum value of here he told x is in this. So maximum it can take numerator can take 64. It can't be 64. It will be less than 64.
ఎస్
If you
సార్.
take denominator more than 64, then definitely less than 1.
ఎస్ సార్.
It will become 0.
ఓకే. స్టెప్ విల్ బికమ్ జీరోనా సార్?
Yes, 0, there is no step function, then it is obviously continuous everywhere. So
Yes,
here,
sir.
everywhere means all real numbers. Right. So now let us see this particular question. Here, first, you should know how to sketch the graph. Mod X graph will be like this. So mod X is defined as plus X for X greater. Actual, in fact, Y equal to X graph will be like this. But that graph only for positive. You cannot take this. For positive means only part of it we have to take. So Y equal to minus X graph will be like this. But that is for only negative values. So this is mod X graph. So here you take mod of X minus 1. The graph will be like this, where y becomes 0 at 1. It basically mod x. There is no change, only shift occurs. So this will be the graph. Now look at this. Analyze this function. How do we analyze here? It is a polynomial. That means x belongs to minus infinity to 1 is continuous. And mod x also continuous. X belongs to 1 to infinity. Uh, I can say he told x greater than 1, but it changes its nature at 3. Let us see here. Boundary, how it affects. Actual graph will be mod of x minus 3 graph will be, it will take a turn at 3. So this will be the graph. But he says you consider this graph after 1. Don't consider before 1. Then this graph will be restricted. So it will be 3 to infinity. 1 will be somewhere here. This will be the graph of which function mod of x minus 3 for greater than or equal to 1. And it is ax square plus bx plus c, which is a polynomial, but it is defined for less than 0. Strictly speaking, how to draw the graph? 2x minus differentiate it f dash x. So x will be 3. That means at 3 it has a least value. It's a parabola concave upwards. At 3 it will have a least value, but it is the actual graph will be up to 3, something like this. But this graph I cannot consider. I have to consider the graph only up to 1. So up to 1 means it's a parabola. We don't know whether it is continuous at 1. Let us check. Limit extends to 1 minus fx. It is related to parabola. So here you have 1 by 4 minus 3 by 2 plus 13 by 4, which is 14 by 4. 7 by 2 minus 3 by 2, which is 4 by 2. For 1 plus fx, we write here more than 1 mod of x minus 3, which is 2. So we say f is continuous because both our right and left limits are equal. Functional value also equal to f of 1 is 1 minus 3. So it is continuous, it is true. But he says question is not true. Is it continuous at 3 means obvious because uh, it is for greater than 1. It is a mod x function. This is everywhere continuous. X greater than f is continuous. That one, these turning points you should be careful. Less than one function, greater than one. Regarding differentiability, here a function f is differentiable at x equal to a. Limit x tends to a fx minus fa by. This exists. This limit exists means maybe its value is 1, minus 1, half. Such kind of thing happens, we say it exists. Let us check differentiability of mod x at x equal to 0. Since it is a modulus function, for continuity we use only a function. But in place of fx, we have different thing for differentiability. Tends to a means it can approach a from right side or left side. I want to check this function differentiability at origin. Mod x minus f of 0. Here f of x is mod x. F of 0 will be mod 0. 0 plus will be more than 0. You get 1. This is our right limit. It is a right hand derivative. So limit left hand derivative, if you find out, limit extends to 0 minus. 0 minus will be minus x by x minus 1. So left hand derivative is not equal to right hand derivative, which implies mod x is not differentiable at x equal to 0. So since it does not exist, it is not differentiable. Graphically, what I say here is checking differentiability. Where sharp edges are there, simply derivative means where you can draw the tangent, that to unique tangent. If you take a graph like this, then at this point I can draw a unique tangent which touches at only one point. If I take a graph like this sharp edge, so I can draw tangent, I can draw tangent, it is not unique. So wherever sharp edges is there, it is not differentiable. That means at x equal to 0, f is not differentiable. So now you can see this graph. Obviously, at 3 you have a sharp edge. So it is not differentiable at x equal to 3. At x equal to 1, it is discontinuous. So obviously not differentiable. 4 comma 2. Not continuous definitely implied not differentiable. So it is not differentiable at x equal to 1 because it is not continuous at that. It is not differentiable at x equal to 3 even though continuous. There it has a sharp edge. So it is not differentiable at these 2 points. Okay.